Hello everyone. In this video, we'll be discussing about some numericals from complex analysis. Right? Okay. So let's do some questions. First question is the value of the integral. You have to find the value of the integral. Okay. Find the value of the integral sine z divided by z sixth z to the power 6 dz. Right? Sine z divided by z to the power 6 dz. Okay. Where c is the circle with the center. C is the circle with the center at z is equal to 0, and the radius is how much? The radius is 1 unit. Alright. So we have to find the integration of this one. So how will we do it? See, first of all we will take this as f of z, right? So what is the f of z? F of z is what? Sine z divided by z to the power 6. That is our f of z, isn't it? So sine z divided by z to the power 6. That is our f of z. Alright. So we know we have to expand sine z here. Otherwise we won't be able to solve it. Okay, sine z will be how much? If we know sine z is z minus zq divided by 3 factorial, zq divided by 3 factorial plus z5 z5 divided by 5 factorial. Okay, minus, it will go on and on like this. Okay, so I will put the value of the sine z here. So it will come as f of z, it will come as f of z is equal to this is 1 by z6 is outside. Okay, 1 by z to the power 6 equal into z minus 1 into z minus zq by 3 factorial plus z fifth by 5 factorial, z fifth by 5 factorial, right? And it will go on and on, isn't it? So if I open the bracket, it will be how much? See, I will open the bracket, it will be 1 by z to the power 5, 1 by z to the power 5 minus 1 by 3 factorial z to the power 3. Okay, and plus 1 by 5 factorial, 1 by 5 factorial 1 by z. Okay, see one thing here, how to calculate the residue here. See, the residue is actually what? The residue is what? Z will be 0 because z is the numerical. Residue at z is equal to 0 will be how much? Residue is always, in this type of cases, residue is the coefficient of 1 by z. Okay, the residue is coefficient of 1 by z, coefficient of 1 by z. Alright, so what is the coefficient of 1 by z here? 1 by 5 factorial. So the answer will be 1 by 5, but this is not the answer, this is the residue only. Okay, 1 by 5 factorial. 1 by 5 factorial is how much? 1 by 120. Okay, 1 by 120. Alright, yeah. So this is a residue. What is the integral? Integral is how much? 2 pi I into sum of all residues. So 2 pi I into sum of all residues. 2 pi I into sum of all residues. Alright. So 2 pi I into how much? 2 pi I, this will be 2 pi I into 120. Right? 2 pi I into 1 divided by 120. This will be what? Pi I by 60. Pi I by 60. So this is your I. Okay. This is the answer. This is your answer. Alright. So this is the question again. See, sine z by z to the power 6. Okay, this type of questions, how will you do? If there is a sin z or something, we have to expand it. Okay, so sin z is equal to z minus z cube divided by 3 factorial plus z cube divided by 5 factorial. Okay, now f of z will be, I will take this z to the power 6 or 1 by z to the power 6 into, I put the value of sin z here, z minus z cube by 3 plus 3 factorial plus z cube by 5 factorial dot dot. Okay, now I will just simply multiply z to the power 6 everywhere. So 1 by z to the power 5 minus 1 by 3 factorial z to the power 3 plus 1 by 5 factorial 1 by z dot dot dot. Okay, so residue of z, residue at z is equal to 0. Why z is equal to 0? Because z6 is the denominator, so I have to equate it to 0, right? So z to the power 0 is one of the poles. This is the pole, right? And here the pole is of the order what? Pole is of the order 5 here, not 6. Okay, so because 1 z was cancelled out, yeah, coefficient of 1 by z will be your residue. Okay, so coefficient is 1 by 5 factorial, that is 1 by 120. So I is equal to how much? 2 pi I into sum of all residues, that is 2 pi I into 120, that is pi I by 60 if 2 are 2 and 120 are cancelled. All right, yeah, this was one of the questions. Okay, uh, okay, next question number 2. Question number 2, the value of the integral 1 by pi integration of 1 by pi integration of minus infinity to infinity, 1 by pi integration of minus infinity to infinity cos x whole divided by x square plus a square dx. Okay, 1 by pi minus infinity to infinity cos x whole divided by x square plus a square dx. In this type, when there is a cos x or sin x in the numerator, what should we do? See, we know e to the power ix. We know e to the power ix is how much? E to the power ix is cos x. E to the power ix is cos x plus I sin x. E to the power ix is cos x plus I sin x. So cos x is the which part? Cos x is the real part, and sin x is what? Sin x is what? Sin x is your imaginary part. Okay, cos x is the real part, sin x is your imaginary part. So I can write this integration as, can I write this integration as the real part of, I can write like this, the real part of what? A real part of 1 by pi. 1 by pi, let it be there like that. 1 by pi minus infinity to infinity cos x means e to the power ix. Real part of minus infinity to infinity e to the power ix divided by x square plus a square dx, isn't it? X square plus a square dx. So now what will I do? I will take this thing as f of z now. See, f of z will be how much? F of z, f of z will be e to the power iz. Forget that 1 by pi, we will calculate that at the end. E to the power iz divided by z square plus a square, isn't it? Now what are the poles? See, poles are z square plus a square. Z square plus a square is equal to 0. Okay, so it's like what? If I do it like this, so this is actually z plus ia. This is actually what? Z plus ia whole into z minus ia whole into z minus ia is equal to 0, isn't it? Z plus ia whole into z minus ia is equal to 0. So from here I can say that z is equal to what? Z is equal to minus ia, z is equal to minus ia, and z is equal to plus ia, isn't it? Z is equal to minus ia and z is equal to plus ia. Okay, so these are the two poles. But see, here the limit is from minus infinity to infinity. All right, when the limit is from minus infinity to infinity, the contour is taken as what? It's minus infinity to infinity. So it's like the whole, like the contour is taken in the upper half of the like this thing plane. Okay, so we take the upper half part, isn't it? So what is in the upper half? We will find only plus ia in the upper half. The plus ia will be here, isn't it? This will be your plus IA, z is equal to plus IA, and this will be your z is equal to minus IA. So which part is the upper half? Is in the upper half? Only plus IA. So we will take only z is equal to plus IA as for the to calculate residue. So we'll calculate residue at what? Z is equal to IA, isn't it? Z is equal to IA is equal to how much? Is equal to limit limit z tends to IA is equal to limit z tends to ia what e to the power iz, sorry, z tends to ia, right, z tends to ia z minus ia, okay, z minus ia whole into e to the power iz whole into e to the power iz divided by z minus ia plus into z plus ia, z minus ia into z plus ia, z minus ia into z plus ia, okay. So z minus ia will be cancelled out. So what is left? Z plus ia. So I'll just put ia there in place of z, isn't it? So this becomes e to the power I into iz, sorry, I into ia whole divided by ia plus ia whole divided by ia plus ia. Okay. So this becomes e to the power minus a. This becomes e to the power minus a whole divided by 2ia. Okay, so this is your what residue, isn't it? This is a residue. So the integral is how much? Integral is 1 by pi was also there, remember, 1 by pi into 2 pi I into 2 pi I into e to the power minus a e to the power minus a whole divided by 2ia 2ia. Pi will be cancelled, 2i will be cancelled, so the answer will be 1 by a into e to the power a. All right. So this is the answer for the second question. I is equal to 1 by 8 into e to the power 8. Okay. So what we did again, we just in place of cos x we wrote what real part of e to the power ix, this one. Okay. And we just then took it as f of z. Okay. Z square plus a square is equal to 0. We calculate the poles from it. These are pole of order 1, isn't it? And we took the upper half only because the limit is from minus infinity to plus infinity. Okay, when it is minus infinity to plus infinity, we do what? We take the upper half only. All right. Yeah. Okay then. Next question, question number 3. Question number 3 is compute. Question number 3 is compute a limit. Compute limit z tends to 0. Compute z tends to 0. A real part of z square. A real part of z square plus imaginary part of z square plus imaginary part of z square imaginary part of z square divided by z square, okay, is equal to how much? Okay, yeah, this came in JST. This question came in JST 2013. Okay, so take your 2 3 minutes and try to solve it. You can pause the video. Okay, real part of z square, let me write it. Z square is how much? Z is how much? Z is your x plus iy. Right, z is equal to x plus iy. Z square is how much? Z square is x square minus y square, okay, plus 2ixy, isn't it? 2ixy. This is your z square. Alright. So, real part of z square is x square minus y square. Imaginary part of x square, z square is 2xy, isn't it? So, we'll just put it here in the place of limit. So, limit z tends to 0, limit z tends to 0, x square minus y square plus imaginary part of z square, that is 2xy, okay, whole divided by z square only, whole divided by z square only, that is what, x square minus y square, x square minus y square plus 2ixy plus 2ixy. All right. Now what, z tends to 0 means what, x tends to 0, y tends to 0, isn't it? So x tends to 0 and y tends to 0. Okay. So now, what will we do? See, we will do what here? Let we will put y is equal to mx. Okay, and we will check y is equal to, put y is equal to mx. So if you put y is equal to mx, this will become limit x tends to 0, x tends to 0, y tends to 0. Okay, x should remain as it is. Y is your mx, so y square becomes m square x square plus 2xy plus 2xy, that is 2x into mx. Okay, 2x into mx whole divided by x square minus m square x square plus 2y x mx. Okay, now x square you can cancel on both numerator and denominator. What will left? What will be left? 1 minus m square plus 2m. Okay, plus 2m whole divided by 1 minus m square, 1 minus m square plus 2im. Alright, plus 2im. So one thing is there, since this whole thing depends on m, okay, since this whole thing depends on m, that will show that limit does not exist. Okay, if the limit, if after the getting the answer, if it depends on m, okay, if it depends on m, which it does, m, and limit x tends to 0, y tends to 0, then what will happen? Limit will not exist. So the answer will be what? Answer will be limit does not exist. Limit does not exist. Okay, so this is another question. This is question number 3. All right. Yeah, this is another variety of question here. Question number 4. Question number 4 will be, see, limit z tends to I, limit z tends to I, z to the power 10 plus 1 divided by z to the power 6 plus 1. Okay, z to the power 6 plus 1. This came in JS 2014. JS 2014. Alright, how to solve this question? Okay, see, I is there in the limit. So, if I put I there on both the numerator and denominator, let's see, I to the power 10 plus 1 divided by I to the power 6 plus 1. I to the power 10 is how much? Do you remember I to the power 10? I to the power 10 is, it's I to the I square. How? It can be written as I to the power 4 into 2 plus 2. I to the power 4 is 1 and its multiple is 1. So it becomes I to the power 2. Okay. These are basic towards the class things. So I don't need to explain them again. So the numerator also becomes I to the power 2, that is minus 1 plus 1. And the denominator also becomes I to the power 6 is I square, that is minus 1 plus 1. Okay. So this becomes what? 0 by 0 form. Okay. So this becomes 0 by 0 form. So we can use L'Hopital rule. Okay. Or L'Hospital rule, whatever you can say. Okay. L'Hopital rule. Okay. So according to that, we can take the derivative on both the numerator and denominator, isn't it? So limit z tends to I. Okay. Limit of the numerator is 10 z to the power 9 divided by z to the power 6 is 6 z to the power 5. Okay. So z to the power 9 is, we can put I now. 10 into I to the power 9 divided by 6 into I to the power 5. Okay. So 10 into I to the power 9 becomes how much? I to the power 8 into I. So that should be I, isn't it? So 10 into I. See, any multiple of 4, if it is the power of I, that will be 1. Okay. 6 into I. Alright. So this whole thing becomes what? 10 by 6, that is 5 by 3. Okay. So this is the answer. Okay. 5 by 3 is your answer. Alright. Yes. Okay. Alright. Okay. So these are some of the questions from complex integration. Okay. Complex analysis that we did today. Okay. We'll solve more questions in the upcoming videos. Okay. Thank you very much.